Welcome back. We are on a mission of answering the exam related questions. Very important. We have got the recent question paper here. We'll start with question number 4, which is about chemical reactions. So let's just go through it so that we can see how we can analyze. Remember, the secret in the organic molecules for all of us is to make sure that at least take 5 minutes in analyzing the flow diagram, and then the answering of the question will become very easy. Study the diagram, the flow diagram below. The reaction 1 is a cracking reaction. We are being told forming 2 organic compounds, W and T, as the only products. Fine. We can see that in this case, if T is an alkene, C4H8, therefore it means that W will be an alkane. So now we don't know what is U, but we'll be guided through. Hopefully, if we check here, we can be guided by this reaction 2. Remember, we come from alkane. Reaction 2, if it's forming haloalkane, immediately we can tell that reaction 2 is substitution. And in this type of substitution, whereby we replace one hydrogen with a bromine, therefore will require one reaction condition, that is sunlight or UV light. So UV light, fine. In this case, meaning that we are going to add bromine, Br2. We'll need Br2. And remember the byproducts. If we have got 2 reactants, we'll have 2 products. Now, we can tell how many carbons, 1, 2, 3, 4. Therefore, this alkane was butane. We can tell that now. Therefore, W is butane. If we know that this is butane and this one can be but1 in or but2 in, then, but this is the reaction 4. We see that if we are heading towards alkene, once we produce double bond, that reaction is elimination. Just same as this one. This is cracking, we are told, reaction 1, which is elimination. This is also elimination. Where do we come from? We come from compound S. We don't know what is that compound S about, but we can track it. From haloalkane, we undergo elimination. Then mean that now we'll now dehydrohalogenate. This one is dehydrohalogenation. That is the most important elimination reaction. Remember, haloalkanes can undergo only 2 reactions. That is a substitution or elimination. In elimination, we'll need 2 reaction condition. That is concentrated sodium hydroxide or strong base, potassium hydroxide, lithium hydroxide, plus strong heat. We need to heat strongly, fine. So which means that now if we dehydrohalogenate here, obviously this will be but1 in, because the Br is at carbon number 1 here, will be but1 in. This is a primary haloalkane. Now from but1 in, we undergo reaction 4 to form S. Remember, alkenes can undergo only 1 reaction, that is addition. Therefore, for us to go to S, then we'll be guided by the questions as we go through. What is S? Because the possibility is that S might be alcohol. That's when we think aloud, S might be alcohol, because if we eliminate from alcohol, we can find an alkene. We are dehydrating there. So currently now we can just say, thinking aloud, then S, let it be an alcohol. S be an alcohol. And if it's an alcohol, if we add water here, add water, that is hydration or addition. Hydration. And then this will be now from but1 in, then the OH will be at carbon number 2. Therefore, this is butane. Butane 2-ol. If this one is butane 2-ol, therefore the alkene here will be now but2 in. but2 in. That is the case. Fine. Almost we are done with the flow diagram. Let's listen to the questions. We took 5 minutes exactly. Define the term cracking. Remember cracking, we said in this case, please make sure that we know the correct way of this cracking, because some books are telling it the way that is not supposed to be. Cracking now will be the breaking down. We must breaking down of the long. In this case, it must be long or longer. You can use the word longer or long, so it's fine if you use that one, but the best one, let's say longer, because we'll have to say shorter that side. Longer chain hydrocarbons into shorter. So the word now longer, shorter, useful molecules should be molecules. Remember, in cracking we can form hydrogen. That's why we are using the word molecules, not hydrocarbons. Not necessarily that if you write hydrocarbons would be wrong, but if you say molecule, that's the perfect way. If you can use the word larger and smaller, then you are wrong. Fine, we go to 4.2. 4.2, look at it. It say, look at this one. They say it's the product of reaction 2. Okay, primary, secondary, or tertiary. This is reaction 2. Remember, since this one we say it's 1-bromopropane, butane. Therefore, it's the bromine is carbon number 1. Therefore, it become a primary. So your answer will be primary. It's a primary haloalkane. Fine. They say give reason for your answer. Why is it primary haloalkane? Then now we put a description there. We'll say now is either you say the bromine, or you can say halogen, or you can even say the functional group. The functional group is bonded to the carbon C atom. Carbon atoms say to the carbon atom that is bonded to one other carbon. So that will be the perfect one. 4.3.1. Fine, let's go to 4.3. They say write down the structural formula of W butane. So that one is very easy. We have already analyzed butane, therefore it will be easy. That's the importance of analyzing. Butane is just 4 carbons, and then it's a hydrocarbon. All the remaining atoms will be hydrogen. Every carbon should be surrounded by 4 bonds and not more or not less. Fine, we get the 3 marks. 4.3.2. We move, they say write down the molecular formula of U. U, remember now there's a but and but. Therefore U meaning that must have C8 now. So it's an alkane, so it should be your C8H18. So your typical octane. Fine. 4.4.1. Let's go and see. According to this question, they say for reaction 2. Reaction 2, remember, is the one that we said it's a substitution, and we're adding bromine there. Name or formula of inorganic reactant. Oh, very good. We have already analyzed. We said in our analysis that we need bromine there. Fine. Therefore, they say name. So it's either you write bromine gas, or you write Br2. That will be okay. 4.2. Then they say in this one, write down the type of reaction. Choose from substitution, addition, or elimination. Good shot. We have already allocated that and say, oh, in our analysis, this is substitution. If you have already analyzed, you will be flowing in most of the questions here. That's the secret of mastering this section. Then the last one on 4.4, they say to us, write down one reaction condition. Oh, we were spot on to say we need sunlight here. So you can just say my examiner, I know this one already analyzes sunlight is needed, or you can write UV light, so no problem. Or some people can just write heat, it's okay. That's that one. No, whether you say gentle, but don't say strong. Strong will be incorrect. Let's go to the last part here, which is almost the same analysis now. They say to us here, sorry for the question that is not that visible. Let me just find the other part of this question paper. I've got another copy that might be very easy to deal with, and also this one will help us if we need it. Let me just put it here. The next question here on the next page, they said to us, fine, they redraw the diagram. They say normally they save learners from flipping the pages back and forth. Now they say again, the flow diagram on page 9 is redrawn for easy reference. That's the reason why it's repeated. 4.5, write down the type of elimination in reaction 3. We have already done that in our analysis to say this is dehydrohalogenation. Yippee, we are very spot on. So 4.5, we have already anticipated that one is dehydrohalogenation. Halogenation. Fine. 4.6. Now, compound R and T are positional isomers. R and T, yes. R and T. Remember we said this one is but 1 in and but 2 in. Fine. Therefore, yes, we agree. Inorganic reagents are shown below, available for reaction 4 and 5. Fine. Remember we said reaction 4 is hydration and reaction 5 is dehydration. So fine. Then write down the balance equation for reaction 4 using structural formulae and the correct inorganic reagent shown above. So you choose any one from the list here. Fine. We know that for dehydration, in this case, where for hydration, we need your organic compound that is but 1 in. Fine. Double bond is at carbon number 1.